So by now we should have a good understanding of the concept of limits. We should know how to evaluate limits when given a graph, and we should also understand when a limit does not exist. In this video, we're going to talk about how to utilize our graphing calculator to help us in evaluating some limits. Here's our first example. Use a graphing utility to graph the following function. Then use the graph and or table feature of the calculator to help evaluate the following limits. So obviously step number one, we want to graph our function f of x. In this case, f of x is equal to x cubed minus 8 divided by 4x minus 8. So we are going to hit y equals and we are going to plug in this function. One thing to be careful of with fractions is that we want to make sure if we have multiple terms in the numerator and denominator that we put parentheses around the entire numerator and denominator. Now, there's also a little technique, little cheat in your calculator if you want to actually get a fraction bar. Once you are in y equals, select the alpha button. That's the green button on your TI-84. Select y equals again and hit enter. And that will actually give you a fraction bar in your calculator. And so then you don't need the parentheses. You can plug it in just as you saw it here, x cubed minus 8 divided by 4x minus 8. And then hit graph. And if you're in your standard 10 by 10 window, you should see this exact image here. Okay, here we have the graph of our function f of x. And we are being asked to evaluate the limit as x approaches 2 from the left, from the right, and our general limit as x approaches 2. Well, here we have x equals 2. And based off of the graph, it almost looks like, okay, as x is approaching 2, my y values are approaching 3. And it's not particularly easy to see exactly what that value is. But we can use the table feature of our calculator to see if we can get a better idea of what's happening. So with your TI-84 in hand, I want you to hit second window. All right, second window is going to bring you to your table setup. And underneath your table setup, I want you to type in 2 for table start and 0.00 for delta table. Also, where it says independent and dependent, both auto should be selected for each one. Now, the reason we want to start our table at 2 is because we are evaluating the limit as x approaches 2. So wherever you're evaluating the limit, that's where you want to start your table. The reason we are plugging in 0.001 for delta table is because that's going to give us a step in our x values that are really close to 2. Meaning it's also going to give out y values that correspond to those x values that are really close to 2. All right, so once you plug this into your table setup, hit second graph, and that will bring you to your table. And once you get to your table, scroll up just a little bit until you have 2 right in the middle of your screen. And you should have something that looks similar to this. And notice that our calculator tells us that there is an error when x is equal to 2. And let's think about why that is the case. If we tried to plug in 2 into this function, we get 8 minus 8. Well, we try to evaluate f of 2, we end up with 0 in the numerator divided by 0. All right, and 0 divided by 0 is undefined. All right, that means we have some sort of discontinuity in our graph of our function. And based off of what we saw in the graph, yeah, this is going to correspond to a hole in the graph. We have a hole when x equals 2. Well, as we know, when there's a hole in the graph, we can still evaluate the limit as x approaches that value. So let's look at our table and interpret what the table is telling us. Here, above 2, I have values of x that are to the left of 2. And notice that as I come this way, the x values are getting closer and closer to 2. Well, as my x values get closer and closer to 2 from the left of 2, what are the y values getting closer and closer to? Well, each consecutive y value is getting closer and closer to 3. Therefore, we can confirm that the limit as x approaches 2 from the left of f of x is indeed equal to 3. Similarly, to evaluate the limit as x approaches 2 from the right, we notice that these numbers down here are values of x that are to the right of 2. And as our x values get closer and closer to 2 from the right of 2, what do the y values get closer and closer to? Right? They get closer and closer to 3 as well. And because the limit from the left of 2 is equal to the limit from the right of 2, we can confirm that the limit as x approaches 2 of f of x is also equal to 3. As my x values get closer and closer to 2 from either side of 2, the y values get closer and closer to 3. Let's take a look at another one. Same idea. Use a graphing utility to graph the following function, then use the graph and or table feature of the calculator to help evaluate the following limits. So let's start off by graphing this function. F of x is equal to the square root of x minus 1 divided by x minus 1. And again, if you want to get that fraction bar, after you go into y equals, hit alpha, the green button, select y equals again, and hit enter. This will give you your fraction bar. Okay, so we plug that in and we hit graph. Now, I've played around with my window a little bit. Notice I've changed my x minimum and my x maximum a little bit, my y minimum and my y maximum a little bit, just to get a better idea. And we can actually tell something's going on here at x equals 1, right? Notice we're evaluating the limit as x approaches 1. And if we tried to plug in 1 for x here, well, notice we end up with 0 divided by 0. Again, the function is undefined at x equals 1, and we actually have a hole in our graph here at x equals 1. Well, doesn't mean we can't evaluate the limit. So it's kind of tough to see just based off of the graph what our y values are getting closer and closer to. So let's use the table feature again. Hit second window. Second window brings you to your table setup. This time, we want to start our table at 1. And the reason we want to start our table at 1 is, well, we're evaluating the limit as x approaches 1. Again, wherever you're evaluating your limit, that's where you should start your table. Delta table should be 0.001 again. You're not really going to change this. Again, we want values that are going to give us x numbers that are close to 1, right? And again, independent and dependent, keep those in auto form. All right. Once we type that in, we can hit second graph, and that will bring us to our table. Scroll up a little bit until we have 1 right in the middle of our screen. And again, yes, it says error at 1. We know our function is undefined. When x equals 1, we have a hole in the graph. Now, above 1, these are values of x that are to the left of 1. And as these x values get closer and closer to 1 from the left, what are the y values getting closer and closer to? Well, the y values are getting closer and closer to 0.5 or 1/2. Similarly, down below here, we have x values that are to the right of 1. And as my x values get closer and closer to 1 from the right of 1, what do the y values get closer and closer to? Well, these all get consecutively closer and closer to 1/2 again. So the limit as x approaches 1 from the left and the limit as x approaches 1 from the right both equal 1/2. Because the limit from the left and right are the same, we can confirm that the limit as x approaches 1 of f of x is equal to 1/2. As my x values approach 1, my y values get closer and closer to 1/2. Let's try one more here. All right, use your graphing utility to graph the following function, then use the graph and or table feature of the calculator to help evaluate the following limit. Here we have our function, f of x is equal to 3x plus 9 divided by the absolute value of x plus 3. Okay, so we can get our fraction bar again, or just simply use parentheses. If you're curious as to how to get your absolute value, all right, to get absolute value, you are going to select the math button, okay? And then you are going to hit the right arrow, and that will bring you over towards what says number, N-U-M at the top. So math, right arrow, that brings you to number, and the first thing that pops up should be abs, A-B-S. And just select enter. That will give you your absolute value option. All right, so we graph our function, arrow, right arrow. There we go. That makes more sense. Right arrow, and then select abs. So now we can graph our function, and if we're in our standard 10 by 10 window, we end up with an image that looks like this. And we notice at x equals -3, we have this discontinuity. All right, our function actually jumps from one set of y values to another set of y values. Well, let's look at our table again. Hit second window. That will bring us to our table setup. And because the limits we are asked to evaluate are at -3, we are going to start our table at -3. Again, delta table, the rest of your settings should all be set up for you. Hit second graph. Second graph will bring you to your table. All right, and scroll up until you have -3 right in the middle. Well, yes, when x equals -3, we get out an error because the function is undefined. Notice again, if we tried to evaluate f of -3, I plug in -3 for x, that gives me 0 divided by 0, the absolute value of 0. All right, so again, the function is going to be undefined when x is equal to -3. Well, let's see if we can't evaluate our limits here. The limit as x approaches -3 from the left. These numbers up here are all x values that are to the left of -3. And as these x values get closer and closer to -3, what do the y values approach? Well, they actually always equal -3. Therefore, the limit as x approaches -3 from the left is going to be -3. Similarly, here I have my x values approaching 3 from the right. -3 from the right of -3. What are my y values? Well, they are always +3. Therefore, the limit as x approaches -3 from the right is equal to +3. And in this case, the limit from the left and the limit from the right are not equal to each other, meaning that the limit as x approaches -3 of our function f of x does not exist. Okay, remember, if the limit from the left does not equal the limit from the right, the limit as x approaches a does not exist. All right, that's using your calculator, graphs, and the table feature to evaluate limits.